Welcome friends, myself Shreyans Nishod, student of BCA branch. Here I am to discuss the internal exam paper of Computer Oriented Numerical Methods of International Institute of Professional Studies DAVV Indore. First question, first internal. The question is here. Write an algorithm or flowchart to solve the following pair of equation for x and y. Given the value of a11, a12, a13, a21, a22, a23, and the equation is a11x1 plus a12x2 equals to a13, and the second equation is a21x1 plus a22x2 equals to a23. You see the table, it having four cases and two subparts of question. The first part is comment on result of case 1 and case 2 when there is a chance of when there is a change of 0.001 in one of the coefficient, and the second subpart is how interchange of equation affect the solution in the case 3 and case 4. Now see the solution. Case 1, according to cost elimination method, converting it into argument matrix. You see the matrix. Now with the help of above matrix, converting argument matrix into a diagonal matrix using 2.5000 as pivot. Then applying a operation on R2. R2 minus R1 into A21 divided by A11. We get the matrix. You see the matrix here, and we are applying for forward elimination phase. 2.5000x1 plus 2.52000x2 equals to 6.2000. It will give x2 equals to 16.9584, and other 2.5000x1 plus 5.2000 into 16.9589 equals to 6.2000. It will give x1, and the x1 is minus 32.79451. Now the case 2, the given metric is here, and by Gauss elimination method, we are applying a operation on R2 minus R1 into A21 divided by A11, converting argument matrix into diagonal matrix with the 2.5000 as pivot. You see the matrix here, and forward elimination phase 2.5000x1 plus 5.200x2, it equals to 6.2000. It will give x2, and the x2 is 12.63265, and for x1 2.500x1 plus 5.200 into 12.63265 equals to 6.200. It will give x1, and x1 is minus 23.795, and the case 3 is the given matrix is here. You see the above matrix can also be written as by Gauss elimination method. We are applying operation on R2 minus R1 into A21 divided by A11. The diagonal matrix is like that. You see the forward elimination phase is 0.00002x1 plus 2.0000x2 equals to 2.000. It will give x2, and the x2 is 0.99998. And now for x1, 0.00002 x1 plus 2.000x0 0.99998, it will give 2.000, and the x1 is x1 equals to 2. And we for last case number 4, the given matrix is, you see the above matrix can be also written as like that. The Gauss elimination method, we applying a operation on R2, the R2 minus R1 into A21 divided by A11. The diagonal matrix is like, and we for forward elimination phase 1.0000x1 plus 2.0000x2 equals to 4.000. It will give the x2, and the x2 is 0.99998, and for x1 1.0000x1 plus 2.000x2 equals to 4.000. It will give the x1 is 2. Now the subpart of question first is, in case of first, the value are x1 equals to minus 32.79451 and the x2 is 16.9589. And in case 2 the value are x1 equals to minus 23.795 and the x2 for 12.63265. Hence we can conclude that when the value of A22 is changed by 0.0001, then the result display of big change in their x1 and x2 values. Subpart B, in case 3 the value are x1 is 2 and the x2 for 0.99998, and in case 4 the value are x1 equals to 2, x2 equals to 0.99998. Hence we can conclude that the interchange of equation does not affect the solution of case 3 and case 4. Thank you for question first.